Okay, more probabilities. Mike's MP3 player contains 50 songs. He listens to 10 songs on random. Determine the probability as a percentage to the nearest hundredth that the playlist contains Mike's 2 favorite songs. Okay. 2 of these songs are special. They're his favorites, so I'm going to redefine this a little bit. Rather than his MP3 player containing 50 songs, I'm going to say it contains his 2 favorite songs and then 48 other songs which are merely good. Good, but not his favorites. And now we have to figure out how many playlists are possible here. First, overall, if we ignore the favorite songs and just to the machine that doesn't know what his favorite songs are, there are 50 songs stored, and we're going to play 10 of them. So 50C10 is the grand total number of things that can happen here. And then we have to work out how many playlists contain his 2 favorites and 8 of the other good songs. So from the 2 favorite songs, we're selecting both. And then from the 48 merely good songs, we're selecting 8 because those have to be a total of 10 songs. So how many ways can that happen? 2C2 is 1. I can skip that part at least. But how about the rest? 48, math left 3, 8. That number. And actually I'm going to do this. Divided by 50, math left 3, 10. So 48C8 divided by 50C10 gives a... I have to multiply by 100 to get a percentage, so it's going to be 3.67%. 3.67% chance of both of those songs coming up. For all this, we didn't care about the order because they didn't say anything about the order, so all these were in combinations. Now in part B, things get a little more complex because they talk about the order. One of his favorite songs appears at the beginning of the 10 songs, and then the other one appears at the end. So now we have all the same stuff as before for which songs get played. 2C2 times 48C8 over 50C10. This is just the probability that both of his favorite songs get played, and now we also have to fret about the order, which I'm going to do as a separate piece. How many ways are there? Once the player has selected 10 songs and is shuffling them up, how many ways can it order those 10 songs? Overall, that would be 10p10. This is not 1. 10p10 is, what is it? 10, math, 2, oop, no, not that. There are, once you have those 10 songs picked out, there are actually 3 million ways, 3.6 million ways that you could lay them out in order. And out of those, how many of the orders would have one favorite at the beginning and one favorite at the end? There are actually 2 ways. You could have his first favorite song at the start and his second favorite at the end, or the other way around. Technically, 2p2, which of course is 2, is the number of orders that you could have where one of his favorites is at the beginning and the other's at the end. So, 2 hurdles you have to get through this time. First, it has to pick out a list which contains your 2 favorite songs. And now, because we're getting picky about the order, we have this second term that says there's 2 ways that this could happen where the favorites are at the start and end of the list out of a total of 10p10 selections. This is going to be a pretty small number. That wasn't too smart of me to clear this because I had part of the answer already ready, but oh well, we'll manage. 48C8 divided by 50C10 times 2p2 divided by 10p10. It's almost impossible for this to happen. This means 2.02461937. I'm just going to write this down so I don't lose it when the calculator goes away. 2.02461937 times 10 to the minus 8. E on a calculator is short for exponent, but it means times 10 to the. So this is a number in scientific notation. So just write that out now. 2.02461937 times 10 to the minus 8. Times 10 to the minus 8 means take this decimal and shift it 8 places to the left. Make this number smaller by 8 steps. After I do that, I'm going to have 0.1, 2, 3, 4, 5, 6, 7, 2.02461937. This is our probability. It's in the lottery scale. It's virtually impossible for this to happen. Now, if we turn this into a percentage, we multiply it by 100. That takes the decimal 2 steps to the right. So now we have 0 point, well, technically it would be 0 point and then 5 zeros and then 20246, but they asked for this as a percentage to the nearest hundredth, which means we do this. And we say, to the nearest hundredth, the percent chance of that thing you described happening is 0. It's so unlikely that even in 10,000 attempts, you shouldn't expect it to happen.